Good morning, all of you. Today we have started one of the interesting chapter in mathematics subpaper, that is the matrix algebra for FY CS semester first. So first we have to calculate the inverse of the given matrix by using the elementary row operations. Also we have to check the given matrix is invertible or that is not. That is, we have to find the value of the determinant of A. If determinant of A which is non-zero, at that time the given matrix A is invertible matrix. So first we have to given the matrix A, that is 1 1 1 1 1 2 1 0 2 2 1 3. So applying on the row operations, that is the elementary row operation, we have to applying, that is the R2. R2, that is the row second. So we have to change R2 minus R1, that is the first operation. So we get, that is the changes only the second operation, that is second row R2. So we have to convert the 0 in, that is A to 1 position. Also we have to use, that is second operation, R3 tends to R3 minus 2 times of R1. So we have to applying, that is the row third. So that is 2 minus 2, that is 0. 1 minus of 1 minus 2, that is minus 1. Okay, next one, that is 3 minus of 4, so that is minus 1. So we have to use, that is the third operation, that is R3 tends to R3 minus R2. So at that time we have to convert the matrix A, it's a row third, into 0 rows. So determinant of A, so determinant of A, that is 1 into minus 1 into 0. Because of the given matrix is the square matrix and below diagonals are converted into 0, at that time we have to using the determinant of A. So in the diagonal end take multiplication, so that is the 0. So matrix A is not A is 0, therefore the matrix A is not invertible. Second one example, also we have to check the matrix. We have to given the 2 by 2 matrix, that is 2 3 minus 1 1. So applying on the row transformation, row second, R2 tends to 2 times of R2 plus R1. So R3 2 3 0 5. So mod of that is the determinant of A, which is equal to 2 into 5, that is 10. So 10 which is not equal to 0, therefore the given matrix A is invertible matrix. Okay, so first one, in that two examples we have to check the given matrix A is invertible or that is not invertible using the elementary row operation. Okay, understand? So second one another method, that is we have to find the solution of the given linear system. Solution of the given linear system by using the matrix. So we have to given the one of the matrix, that is the solution of the linear system. So we have to given the matrix 1 minus 1 0 0 minus 4. Second row, that is 0 1 minus 3 0 minus 7. Third one, that is 0 0 1 minus 3 minus 1. Fourth one, that is 0 0 0 2 4. So first we have to write the equation form. So first one, that is x1 minus x2, which is equal to minus 4, that is the equation number 1. Second one, that is the x2 minus 3 times of x3 equal to minus 7. Third one, that is the x3 minus x3 times of x4, which is equal to minus 1. And last one equation, that is 2 times of x4, which is equal to 4. That implies x4, which is equal to 4 divided by 2, that is 2. So value of x4, that is the 2. So put equation 4 in, that is the equation 3. So x3 minus 3 times of x4, which is equal to minus 1. So x3 minus 3 into 2, that is 6, which is equal to minus 1. So x3, which is equal to minus 1 plus 6, that is the plus 5. So value of x3, that is 5. So put that value of x3 in equation 2, we give the value of x2. So we have to put up the value of x3, that is 5. So 5 3 15. So x2 minus 15 equal to minus 7. So x2, which is equal to minus 7 plus 15. So x2, which is equal to 8. So put the value of x2 in equation 1. We get the value of x2, which is equal to 8. Putting in the equation 1, we get the value of that is the x1 which is equal to minus 4 plus 8, that is the 4. So x1 which is equal to 4. Okay, so this one is the solution of the, find the solution of the linear system. Okay, also another type of the solution system, 1 minute. Okay, so that is the B. So matrix B. Second example, we have to given the equation that is the a minus 1 minus 4 9 0 0 1 7 0. Next one, that is next, that is the 0 1 7 0 0 0 2 0. So that equations right in that is sorry, that matrix are right in the equation form. So x1 minus 4 times of x2 plus 9 of x3 equal to 0, x2 plus 7 of x3 equal to 0. So 2 times of x3 equal to 0, that implies x3 equal to 0. So value of x3 put in the equation 2, we gives the x2 equal to 0. Also x2 and x3 put in the equation 1, we use the value of x1 which is equal to 0. Therefore the given matrix has a trivial solution, which means that the all values of the variables x1 which is equal to 0, x2 which is equal to 0, x3 which is equal to 0. Okay, so next one. Next also we have to given the another matrix. For the given argument matrix, state the next two elementary row operations to solve the system. Okay, so we have to given this one, that is the system of linear equations. So that system of linear equations right in the matrix form, we have to convert into equation form. So we use that is the first equation, that is x1 minus 4 times of x2 plus 5 times of x3 equal to 7. Okay, next one, that is x2 which is equal to 3 times of x3 equal to 6. So x3 which is equal to 2, that is the equation number third, and the last one equation number 4, that is x4 which is equal to minus 5. So put equation 3 in equation 2. So value of x3 equal to 2, we have to put in the equation 2. So we use that is the equation. So x2 minus 3 times of x3 equal to 6. So x2 which is equal to 6 plus 6, that is 12. So value of x2, that is 12. So put that value of x2 in equation 5. Sorry. So value of equation 3, that is value of x2, put in equation 1. We get the value of x1 minus 4 times of x2 plus 5 times of x3 equal to 7. So value of x2, that is 12. Value of x3, that is 2. Value of x4, that is minus 5. Putting in the equation 1, we use the value of x1, that is the 45. So we have to find the four variables x1, x2, x3, x4. Value of x1, that is 45. Value of x2, that is 12. Value of x3, that is minus 5. Value of x4, that is 2. Okay, so x1, x2, x3, x4, four values we have to assign and we have to find. Okay, so this type of equation, that is the system of the linear equation, we have to given, or that is argument matrix we have to given. So we have to find the values of the variables x1, x2, x3 and so on, or that is x, y, z also. Okay, so another example, we have to given the matrix argument matrix. So that argument matrix, we have to apply the first row operations for the row 4. So R4 which is equal to R4 minus 3 times of R3. So first equation, so x1 minus 6 times of x2 plus 4 times of x3 equal to minus 1. Second one, that is 2 times of x2 minus 7 x3 equal to 4. So x3 plus 2 times of x4 equal to minus 3. Next one, that is minus 5 times of x4 equal to 15. So value of x4 equal to minus 15 divided by 5. That is the x4 which is equal to minus 3. Okay. So put that equation 4 in equation 3. So value of x3 plus 2 times of x4 equal to minus 3. So x3 plus 2 times of minus x3, that is minus 6. So minus 6 goes to that is right hand side. So we getting that is the plus 6. So x3 equal to minus 3 plus 6. So that is 3. So x3 equal to 3. So put equation 5 into, so 2 times of x2 minus 7 times of x3 equal to 4. So 2 times of x2 minus 7 into 3, that is 21, which is equal to 4. So 2 times of x2 minus 21 equal to 4. So 2 times of x2 equal to 4 plus 21, that is 25. So x2 equal to 25 divided by 2. So that x2 and x3 put in equation 1, we get the values of x1. So x1 minus 6 into 25 divided by 2 plus 4 into 3 equal to minus 1. So 6 into 25 divided by 2, that is the 3. 3 into 25, that is 75. So x1 minus 75 plus 4 3 12 equal to 1. So that is x1, which is equal to minus 1 minus 12 minus 1 minus 12 plus 75. So we get the value of x1, that is 62. So this is the another we have to solve the equations. So x1 equal to 62, x2 equal to 25 divided by 2, x3 equal to 3. Next one, that is x4, which is equal to minus 3. Okay. So this type of equations we have to solve by using the solution of the given linear systems. So another example, the given system is consistent or not, we have to solve. It means that the given system has a solution, that system is consistent or inconsistent, or it has no solution. Okay. So first one, we have to given the two equations, x1 plus 5 times of x equal to 7, minus 2 times of x1 minus 7 times of x2 equal to minus 5. Okay, so we have to write that equation in the matrix form. So minus 1 5 7 divide second row, that is minus 2 minus 7 minus 5. So applying on the row transformation, r2 tends to r2 plus 2 times of r1. So 1 5 7 0 3 9. Okay, so applying on that, so equation x4 which is equal to minus 3, put in equation 3. So we get the value of x3 equal to 3. Next, applying on the value of x3 and value of x4, put in the equation 2, we get the value of x2, that is the 25 divided by 2. Okay, so this one type of, that is the example of the system of the linear equation, that is the consistent or not. Okay. Okay, thank you. So we will stop here. Okay, have a nice day.